Hello, my name is Sam Shabowski, and I'm the marketing coordinator here at Fax. And on behalf of Fax, as well as Bullard, we want to thank everyone for attending today's webinar, Clear Vision, Safe Work, Preventing Eye and Face Injuries. This webinar marks the first installment of a collaborative four-part series between Fax and Bullard. For those who participated in our series last year in any capacity, welcome back. And for those joining us for the first time, we're delighted to have you. Our goal for this series, similar to last year's, is to educate. We want to make sure that everyone that you and your teams are in contact with stay healthy and safe. And with that, we have Bullard, who is a leading manufacturer of PPE, providing both head and respiratory protection for industrial and life science users. Their product line includes respiratory gear, full face protection, a diverse selection of hard hats and those accessories, and a wide range of other safety equipment. And the other partner, Fax, is a nationwide industrial hygiene consulting firm that offers a wide range of services from PPE fittings, health and safety plans, environmental testing services, mold, lead, and asbestos surveys, and so much more. And moving on to our presenter for today, which is Fax's very own Brad Burrs. He is a senior project manager and one of our certified industrial hygienists out of the Detroit, Michigan office of ours. Brad has been a part of this industry for over 15 years, doing a plethora of work for private as well as consulting jobs. He is a true, legend in the industry when it comes to the amount of work he's done. He even teaches on the side. So we're really pleased to have Brad to be able to present today on such an important topic. And before I leave it off for Brad, we just want to take over with some of the kind of nuts and bolts of GoToWebinar. First and foremost, you are on a listen-only mode, so you won't be able to talk. But if you do have any comments or questions, please feel free to add them into the kind of chat feature, which is in the top right there. We're going to try to get to any and all questions at the end with our Q&A portion of the webinar. But if we don't get to them, we will for sure reach back out to you after to get those answered. As well as you will be seeing a polling question option come out from time to time. Those are during our knowledge checks. Those checks are going to be multiple choice questions that will pop up on your screen. We would love to see you interact with that. So pick an answer, and then we'll kind of keep that going. And lastly, if you want a certificate of attendance today, feel free to reach out to either Fax or Bullard, and we can for sure help you out, or put it into the chat, and we'll get that to you by the end of the week. And lastly, this is just a reminder, this is being recorded, and we will be sending out follow-up emails within a day or so with a link to the presentation, so you can feel free to share that to anyone who wasn't able to come, or just if you just need to help re-educate yourself later on. And with that, we want to leave it up to Brad. And here we go.
Thank you very much, Sam. And good afternoon / morning to everyone, depending on where you're listening in from across the country. And thank you very much for attending. So today I'm really happy to be here to speak about a very critical aspect of workplace safety, and that is protecting our eyes and faces from injuries. We all know that in just a split second, an accident can happen and result in serious life-changing consequences. However, on the topic of eye and face injuries, we're going to discuss, and you're going to hear, that most of these injuries are entirely preventable by taking the right precautions, having the right training, and by utilizing the correct protective equipment. So today we're going to explore the most common causes of eye and face injuries and how they happen. We're going to discuss relevant OSHA and ANSI safety standards that guide workplace protection for eye and face injury prevention. We'll talk about a wide array of PPE that's available, some of their strengths, and how to select the right one for the job, as well as discuss best practices for emergency equipment that help reduce the severity of injuries when accidents, unfortunately, do occur. So with that, let's get started. So before we dive into more of the risks and statistics, I want to take a step back and ask, why is eye and face protection such a big deal? Why is it so important? The reality is eye injuries are not just a minor inconvenience. They often lead to long-term vision damage, lost work time, and costly medical expenses. That's why prioritizing proper protection isn't just about compliance. It's really about keeping workers safe and helping businesses run smoothly. So by choosing to implement the right controls, we can do a number of things. We can prevent serious injuries that can affect someone's life, their vision for the rest of their life. We can reduce lost time workdays, medical costs, which have a direct impact on both productivity and insurance. We're obviously going to ensure compliance with safety regulations, which honestly, are not just a legal requirement, but a fundamental responsibility. We can also protect workers from a wide range of hazards, including exposure to physical, chemical substances, and radiant energy risks. These are not just check boxes on a safety list. They are essential steps towards fostering a safety culture and a safety-first workplace. So again, today we're going to break down on why some of these injuries happen, how we can reduce these risks, and what you need to know about PPE and compliance to help keep workers safe. So starting with some numbers, according to the International Labor Organization, or ILO, the world over, around 13 million people live with vision impairment linked to their work, with an estimated 3.5 million eye injuries occurring in the workplace every year globally. Here in the US, according to the National Eye Institute, under the NIH, or National Institutes of Health, about 2,000 work-related eye injuries occur every single day here in the US. This chart here on the left from the Bureau of Labor Statistics shows that about 20,000 lost time eye injuries occur every year. That's 20,000 people experiencing pain, vision impairments, and oftentimes permanent damage just from not having the right protection. Those are some pretty staggering statistics. Beyond the human cost, the injuries add up to over $400 billion globally per year, with $300 million annually in the US for lost productivity, medical expenses, and workers' comp costs. But again, the real kicker here is that NIOSH estimates 90% of these injuries to be preventable through the use of proper PPE. So why do so many injuries still happen? And the answer to that is it often comes down to a lack of awareness, improper PPE selection, or simply failing to wear the right protection when it's needed. And that's why this conversation is so important. So when it comes to eye and face protection, OSHA has clear expectations. Under 29 CFR 1910-133 for general industry and 102 for construction, employers must provide appropriate PPE and ensure its use. That means things like safety glasses, safety goggles, or face shields must be issued based on the hazards that are present. But the catch here is it's not just about providing PPE. The PPE must meet ANSI Z87.1 standards for things like impact resistance, chemical protection, and durability. If PPE doesn't meet these standards, it just will not do its job when workers need it most. So on the topic of ANSI Z87.1, I want to help you understand what that really means. So the American National Standards Institute, or ANSI, along with the International Safety Equipment Association, ISEA, have developed this and other standards, which establish requirements for both occupational and educational eye and face protection to protect against impact, chemicals, dust, and radiation hazards. So by ensuring that workers have the right eye and face protection, it starts by understanding this ANSI standard. ANSI Z87.1 is the gold standard for safety eyewear, ensuring that the PPE meets rigorous impact-resistant testing, optical clarity requirements, as well as hazard protection requirements. So in short, the ANSI standard ensures that PPE meets several performance and durability criteria. One of the most important features of the Z87.1 standard is its certification for impact resistance. Both safety glasses and safety goggles have to pass very high velocity and high mass impact tests to ensure that they provide adequate protection against things like flying debris, tools, and other hazards. These tests help confirm that the lenses that they're made out of can withstand sudden impacts without shattering or breaking, which is a critical factor in preventing workplace eye injuries. What this means is that workers wearing ANSI-compliant eyewear can count on clear, distortion-free vision while also being shielded from UV radiation and chemical splashes. So beyond just impact resistance, ANSI Z87.1 includes specific requirements for things like optical clarity, UV protection, and splash resistance. If you look at a pair of ANSI-approved glasses, you'll see that they come with specific markings to indicate the level of protection that they provide. For example, a Z87 plus sign after it indicates very high impact resistance. A D3 rating will provide protection from liquid splashes. A D5 rating offers dust protection. Something with a U6 rating on it will provide UV filtration. And a W marking indicates a welding filter shade rating. We'll talk about those in a little bit more detail here shortly. So coming up to our first knowledge check. According to the National Eye Institute and National Institute of Health, about blank work-related eye injuries occur every single year in the United States.
So it looks like, Brad, looks like most of the answers came for 20,000.
Okay. Well, the answer is 730,000. Right? A couple of slides ago, we talked about 2,000 per day. So 2,000 per day over a full year is about 730,000 yearly work-related eye injuries. So who actually needs eye and face protection? In short, a lot of people, whether you're in construction or manufacturing or working in a lab, PPE is definitely needed for debris and chemical hazards. However, it does not just stop there. Welders, electricians, healthcare professionals, they all rely on specialized eye protection to help prevent things like burns, electrical arc exposure, and biohazardous risks. Effectively, if a job involves flying debris, hazardous materials, or intense light exposure, eye and face PPE is essential. So when we think about eye and face injuries, there isn't just one risk, right? There's multiple hazards depending on the type of work that's being performed. So according to the Bureau of Labor Statistics, or BLS, workers in these occupational groups here in the chart tend to experience injuries mostly from flying objects, chemicals, harmful UV radiation, or a combination of these types of hazards. Again, looking at this BLS data, you can see that injuries just to the eyes accounted for 37% of all head injuries involving lost time or days away from work. So there's a few key hazards that stand out when you look at the data. First, flying objects. like dust, wood chips, metal fragments, are a major risk, especially in construction and manufacturing. Then we have chemical splashes, and fumes, which can be dangerous even in small amounts. Radiation exposure from UV, infrared, or lasers can also cause serious damage, particularly in welding or lab settings. Finally, in healthcare and certain industrial settings, bloodborne pathogens and biohazards are also a major concern. Understanding these hazards and understanding these risks is the first step towards choosing the right protective measures, and that's what we're going to talk about next. So choosing the right PPE is not just about grabbing the nearest pair of safety glasses. It's about matching protection to the specific hazard. And that's a recurring theme that you're going to hear over the next several slides. Firstly, in identifying these workplace hazards, we want to understand if there's a risk from an impact, risk from a splash, risk from dust. We then want to select the PPE based on the type of exposure and understand if the job is going to require goggles, a face shield, or some specialty eyewear. It's also critical that we ensure proper fit and comfort, because if PPE isn't comfortable, workers are much less likely to wear it correctly. Of course, training also plays a huge role in this, because even the best PPE won't work if it's not used properly. So it really is not just about compliance. It's about ensuring what you choose actually protects people in real world conditions. Preventing eye and face injuries starts with knowing the risks. And that's why hazard assessments are critical. We need to look at job tasks, environmental conditions, and potential hazards before selecting the right PPE. For example, if workers are exposed to flying debris, simple safety glasses might not be enough. They may need goggles or a face shield. When chemicals are involved, splash protection is key. If we align our PPE selection with the specific hazards, we can better reduce injuries and improve compliance. We'll come back to hazard and risk assessments in a little more detail, but understanding the different types of protection that's available, as well as some key considerations for the selection, will help give you the right mindset and background in the selection of choosing PPE for the risk and task at hand. There is a wide variety of eye and face protection available, beginning with safety glasses, right, which are great for general hazards and must meet Z87.1 standards for impact resistance. When it comes to safety goggles, oftentimes they do offer a sealed fit with either direct or indirect ventilation, depending on the hazard, and can be ideal for chemical splashes or dust. Face shields are really good for protecting against large debris and splashes as well, but should always be worn with safety glasses underneath. Welding helmets shield welders and workers from intense light and UV and infrared radiation, and they also must meet Z87.1 standards. The specialty eyewear that's available for laser protection, specific chemical resistant eyewear, as well as prescription safety glasses are also widely available. Again, the key here is choosing the right protection for the task at hand. Safety glasses are by far the most common form of eye protection, but they are not all created equally. To be compliant, they have to meet Z87.1 standards, which ensure reliable impact resistance. If you have a pair of safety glasses handy, the next time you pick one up, you'll see markings like Z87 or Z87 Plus. So what's the difference there? The difference is Z87 Plus glasses undergo a higher impact testing, meaning they can withstand impacts of something like a steel ball traveling at upwards of 150 feet per second. If you're working with liquids or fine particulate, you want to look for D3, D4, or D5 ratings, which indicate protection against those things. Beyond the impact ratings, choosing the right lens also matters. Clear lenses are pretty standard, but if you're exposed to very bright environments, having tinted or polarized lenses can further help reduce things like glare and UV exposure. And it's also not forget about side shields, especially for safety glasses, which provide additional protection in environments with high impact or flying debris. If you do wear prescription glasses, they have to meet Z87.1 standard, or you need to wear a pair of compliant, over the glasses, over your prescription lenses to help ensure full protection. Bottom line is that safety glasses have to be properly rated, properly worn, and properly selected. When extra protection is needed, safety goggles offer a sealed fit, which is crucial for chemical splashes, dust, and airborne particulate. Goggles offer a higher level of protection than safety glasses alone, which make them essential in labs, operations involving chemical handling, or heavy dust environments. If you're working with chemicals, look for the D3 rated goggles to ensure splash protection. And if you need dust protection, look for the D4 or D5 ratings, which indicate defense against both coarse and fine particulates. Furthermore, in selecting the right goggles, you want to understand the ventilation requirements that will be determined based on the environment that you'll be wearing them in. Direct vented goggles allow airflow, but do not protect against liquids. While indirect vented goggles will block splashes and help reduce fogging. But if you need full protection against vapors or fine dust, you want to have non-vented goggles. That's your best choice. Many of these goggles also offer anti-fog and scratch-resistant coatings to further improve visibility and durability as well. Again, if you wear prescription glasses, make sure your goggles either fit over them or you're wearing ANSI-approved prescription goggles. So remember, eye protection is only effective when it's properly selected, properly fitted, and properly worn. Face shields are also an important part of eye and face protection, but there's a key point when wearing them. They should never be used alone. OSHA makes it clear that face shields are secondary protection, meaning they have to be worn with safety glasses or goggles underneath them that meet Z87.1 standards. You can think of these face shields as an extra layer of protection, which can be especially useful when you're grinding, handling chemicals, or performing medical procedures where splashes could be a concern. So what makes a face shield compliant? First, you need to look for the Z87 or Z87 plus marking, which again tells you that that face shield is designed for a specific impact resistance rating. Working with liquids or chemicals, D3 shields are needed, and the D5 shields are best for fine dust. All these face shields that are ANSI approved undergo rigorous impact testing with a 3/4 inch steel ball traveling at least 300 feet per second. That's a serious test of durability. The type of material that the shield is made of is also critical. A polycarbonate type of shield is great for impact and heat resistance, while acetate shields are better for chemical splashes. If you're dealing with flying debris, a wire mesh face shield might be the right choice, but no matter what you choose, full face coverage and proper fit are critical to ensure real world protection. And just remember that the face shields are an added layer of defense, not a replacement for safety glasses or goggles. When it comes to welding, protecting your eyes and face is not optional. It's a necessity. Welding helmets play a crucial role in shielding workers from the electromagnetic energy given off by an arc or by a flame when you're doing torch cutting, which can both injure workers' eyes. According to OSHA, welding helmets or hand shields are mandatory during any welding or cutting operations. The welding helmets have to meet Z87.1 standards as well to ensure they provide effective protection against optical radiation. If you're wondering what makes a welding helmet compliant, You need to first look at the filter of the lenses to ensure they have the correct shade to block the harmful UV or IR radiation. Second, you can choose to have a helmet that offers either an auto darkening feature, which adjusts its lens shade automatically, or a passive helmet that stays at a fixed shade. Again, welding helmets have to be durable, impact resistant, and provide full coverage for the face and neck to reduce the risk of burns or injuries. So welding helmets are definitely not a one-size-fits-all solution. Different types of welding require helmets to have filter lenses with the correct shade number to provide the appropriate level of protection. And that is largely dependent on not only the type of welding, but also the amperage involved. The shade number indicates the intensity of light radiation that's allowed to pass through the filter lens to one's eyes. For example, if you're doing shielded metal arc welding, you need a minimum lens shade of 7 or more, again, depending on the amperage. Something like gas tungsten arc welding typically requires a minimum shade rating of an 8, while plasma arc cutting needs minimum shade of at least an 8 as well. If you refer to the OSHA standards, they not only outline these minimum requirements, but they also incorporate the ANSI Z87-1 standards by reference. Generally, as a rule of thumb, you want to start with a shade that's too dark to even see the weld zone, then go one shade lighter to allow you a sufficient view of the weld zone without going below the minimum required rating. Oftentimes when doing oxy-fuel gas welding or cutting where the torch produces a very intense yellow light, it's better to use a filter lens that absorbs the yellow light or sodium line within the visible light of the spectrum for the operation. Beyond just the shade number, there's also factors to consider when you're selecting a welding helmet, like comfort and adjustability are especially key, especially if you're going to be welding for a long time throughout the shift. Having a well-fitted helmet with a good suspension can help reduce things like neck strain. If you're using an auto darkening helmet, you want to make sure that it has at least 4 sensors to prevent exposure to flashes, and the weight of the helmet itself also matters. Lighter helmets, no surprise, can reduce fatigue over time. And for those who do a lot of switching back and forth between welding and grinding, there are helmets out there that provide a grind mode that can make jobs much easier without having to compromise safety and switch between grinding and welding protection. They're integrated into one helmet. There's a lot of specialty eyewear available as well, and some jobs require it. For example, laser safety glasses are designed to block specific wavelengths of that laser light. Chemical resistant eyewear can provide extra splash protection and it's crucial in both labs and chemical handling tasks. Aluminized hoods provide protection in high heat environments such as foundries or steel mills. And again, prescription glasses are our specialty, and they allow workers with vision needs to stay protected without compromising the clarity of their job or work environment. Key here is that standard safety glasses may not be enough in certain high-risk environments, and employers need to provide the PPE suited to the specific hazards present. And for our next knowledge check here, so ANSI D3, D4, and D5 ratings protect against liquids and dust. Those ratings are specific to various liquids and dust, whether they're coarse or fine.
Yeah, Brad, that was mostly everyone chose that answer.
Fantastic. So when it comes to who's responsible we're implementing all these solutions, both the employer and the employee have responsibilities. The employers have both a legal and ethical duty to protect their workers. And that starts with conducting hazard assessments so the risks are clearly understood, providing correct PPE and ensuring that they're ANSI compliant. Employers have to provide training on the proper use of the PPE because the knowledge of that specific item and how to use it is very important. It's absolutely critical. Employers also have to enforce compliance because PPE that is not worn is not protecting anyone. But the protection goes both ways. While the employers have to provide the PPE, employees are responsible for using it correctly, assuming they've been trained and provided with the correct type of protection. This means wearing required PPE at all times, maintaining and inspecting your PPE regularly because damaged PPE cannot do its job. Need to report any damage or defective PPE so it can be replaced. You need to follow workplace safety protocols because even the best equipment will not help if unsafe behaviors continue. At the end of the day, safety is a shared responsibility, and it takes a commitment from both employers and employees to make iron-based protection effective. Even with the right PPE, unfortunately, mistakes can happen, and oftentimes they'll lead to serious injuries. Some of the most common mistakes when using PPE include using the wrong PPE for the task, like wearing safety glasses when goggles are needed, wearing damaged or poorly fitted PPE because scratched lenses or loose-fitting goggles or broken side shields compromise protection. Neglecting to clean or maintain your PPE results in dirty lenses, which can obscure vision, and a lack of maintenance can lead to unnoticed defects. Also, removing PPE too soon. Many injuries happen in seconds when someone takes off their protection before the hazard is fully controlled or they're out of that environment. And of course, simply not wearing PPE is a all too common mistake. Fortunately, avoiding these mistakes is simple. Right? You want to provide the PPE, train workers on how to use it, enforce compliance, all in an effort to foster and create a culture of safety. So let's look at a real-world example of why eye protection is so important. I have a case study here. So this particular case study happened at a company called Troy Lighting. It involved a worker who was using a grinder to polish a metal piece. While they were utilizing that grinder, the piece slipped from their hand and flew straight into his eye. The worst part here is that he wasn't wearing any protection, even though the goggles and the PPE were provided and available on site. Obviously this was a preventable injury. Thinking about that, it being a completely preventable injury, all it would have taken was to put on a pair of safety goggles, safety glasses, or a face shield, depending on the specific nature of what they were grinding or polishing. Had that been done, the worker would have walked away most likely without a trip to the emergency room or the doctor, would have walked away without pain, would have walked away without potential long-term effects on their vision. In this case particularly highlights a few key points. First, PPE is useless if it's not actually worn. Second, these incidents happen in an instant. You don't get a warning. For anyone that's used a grinder or a polisher, we're talking about extremely high RPMs, and things happen fast. Even when we know better, unfortunately, it's in human nature to sometimes take shortcuts, and that's why it's so important to consistently reinforce safety daily. If the worker would have worn their PPE, this would have been preventable. PPE compliance is not optional. It is an absolute necessity. Again, the employers have to enforce PPE use, and employees have to take the responsibility for their safety assuming they have been provided with the protective equipment that's required and have been trained appropriately on their use. If you were in this person's position, ask yourself if you would take this risk. Because at the end of the day, it is truly your vision, that's on the line. So coming back to hazard and risk assessments, you need to understand the difference between a hazard assessment and a risk assessment, because these two processes work together to help ensure adequate protection in work environments. A hazard assessment focuses on identifying what hazards exist in the workplace. This includes recognizing tasks that generate things like flying particles, chemical splashes, or impact risks. We do that by observing work processes. We assess the source of the hazards, whether it's grinding or welding or chemical handling, and we document those findings so we can determine whether protective measures are necessary. And on the other hand, a risk assessment goes a step further by evaluating how dangerous the hazard is. And that involves analyzing both exposure frequency and duration, and evaluating the effectiveness of existing controls if present. Then can assign a risk level. Maybe it's low, moderate, or high based on the potential harm. As an example, simply identifying that a task generates flying debris is not enough. You have to also consider factors like how often the individual workers are exposed, what, if any, controls are in place, and how severe an injury could be if someone's unprotected. But together, hazard and risk assessments provide a much more comprehensive approach to eye and face protection. And while the hazard assessment helps us understand what risks are present, the risk assessment helps us prioritize the most effective safety controls. Let's take a look at how hazard and risk assessments apply to a real-world scenario. Consider the task of grinding on metal, similar to the first case study. A hazard assessment identifies flying particles as a primary danger. However, that alone doesn't provide enough information. A risk assessment is needed to determine how severe that risk is based on factors such as the availability of face shields and safety glasses, the frequency of exposure, and the effectiveness of any existing machine guards. Once you understand that, you can then implement control measures to further reduce risk. And always the best approach follows the hierarchy of controls, starting with engineering controls, in this instance using machine guards, possibly local exhaust ventilation to contain and remove hazards, followed by administrative controls like providing training, having standard operating procedures or SOPs in place, or even limiting worker exposure time. Lastly, we need to select the right PPE, assuming the engineering and administrative controls were not enough to eliminate or reduce the risk to an acceptable level. Again, key takeaway is that hazard assessments tell us what dangers exist, and the risk assessments help us apply the right level of protection to keep people safe. So another real-world example of a case study of how hazard and risk assessment made a huge impact on worker safety. A company, Freight Car America, which is a rail car manufacturing company, was facing a pretty serious problem. Their welders were at very high risk of injuries due to airborne particles and welding fumes combined. Every day where workers were exposed to metal debris and irritants that led to foreign body eye injuries. And they were not just seeing all these types of injuries. They were seeing many of these types of injuries, with most of them being eye injuries caused by foreign bodies and not the result of direct impacts through the rest of the process. So to tackle this, they started with the hazard assessment, which confirmed that welding and grinding operations were generating dangerous airborne debris. They then conducted a risk assessment, which revealed the likelihood of eye injuries was high because workers weren't fully protected, and that was evident by the number of injuries that they were seeing. So what do they do about it? Instead of just handing out more safety glasses, they found a much better solution. In this instance, they determined that a powered air purifying respirator or a PAPR would be best. These didn't just provide respiratory protection, they also had built-in face shields and eye protection, ensuring that the welders had full coverage from all airborne hazards. The result of implementing these PAPRs was a 70% reduction in eye injuries, which is just a huge improvement. And they did that simply by identifying the risks, identifying the hazards, and implementing the right controls. This is a perfect example of why hazard and risk assessments are not just check the box exercises. They are about finding real solutions that actually protect workers. Because at the end of the day, safety is not just about compliance. It's about making sure everyone goes home with their vision intact, about going home the way they came into work that day. I'm sure a lot of you on the call right now perform hazard risk assessments, as a part of your job. When you're doing that, next time, ask yourself, are you truly doing this for the protection of the workers? And is there a better way to approach this? And while PPE is definitely important, right, it is the last line of defense, not the first. Need to start by following the hierarchy of controls. And when evaluating controls and determining engineering controls, which help reduce or eliminate hazards at their source, those make the workplace, inherently safer. Some examples include, machine guarding to prevent debris from flying towards workers, ventilation systems, which can help control, dust, vapors, or enclosed systems to further protect against splashes or high impact hazards. By implementing engineering controls first, we can reduce our reliance on PPE alone and create a safer work environment overall. Beyond engineering solutions, we also have administrative controls, which focus on changing behaviors and workplace practices to help reduce injuries, eye and face hazards. Some key examples of administrative controls would be implementing safe work procedures, right, which establish step-by-step protocols to further minimize risk. We want to schedule and implement regular and effective safety training, because the knowledge that you're imparting on your workforce is just as important as any PPE that might be issued later on. You also need to have a policy of enforcement, making sure that people are actually using the protective measures that are put in place and provided. And administrative controls are especially important when engineering solutions just aren't enough, to eliminate the hazard completely. We always emphasize that PPE should be the last line of defense, not the first. Why is that? Again, because engineering and administrative controls are designed to remove or reduce the hazard itself, while PPE only protects the worker if it's worn correctly and consistently. That being said, when PPE is necessary, it must be properly selected based on the hazard or hazards. It must be worn correctly at all times, and it needs to be regularly maintained to ensure it remains effective. Employers have to provide the PPE, and workers have to use it responsibly. And together, that's how we ensure real, true protection. One more knowledge check. A blank assessment evaluated exposure frequency and likelihood of injury due to flying particles, initially identified during a blank assessment.
Looks like it was risk and hazard was what most people pointed to.
Yeah, they were correct. That was had it backwards. You're right. Having PPE, again, is just not enough. It has to be worn correctly. So here's what proper eye protection looks like. One, you need to ensure a secure fit, because gaps around the edges can allow debris, dust, or liquids to get in. You need to use side shields because they provide additional protection from things like lateral impact hazards. Also, need to regularly replace damaged or worn out PPE, because those compromise visibility and therefore compromise protection. Even small adjustments like properly tightening straps or adjusting the nose bridge can make a big difference in comfort and effectiveness. So PPE is only effective if it's in good condition. And to help keep it that way, here's what you should do. You want to regularly inspect it every day, right? Look for scratches, cracks, loose components. Clean it properly, following manufacturer guidelines to avoid further damaging it. And you need to store it correctly, keeping it in a clean, dry place away from heat or chemicals. Again, scratched or dirty lenses reduce visibility, and that can lead to accidents. Properly maintaining your PPE ensures that it's ready when you need it to protect when you're at work. And while PPE is absolutely critical, it's very important to recognize its limitations. PPE, again, does not eliminate the hazard. It only helps to reduce the risk of injury or the severity of injury. Protection can decrease over time, especially if the PPE materials degrade. Furthermore, improper use weakens its effectiveness. And if workers don't wear or maintain it correctly, it will not provide the intended protection. Again, this helps reinforce that PPE should always be used in combination with engineering and administrative controls, never as a standalone solution. So unfortunately, when chemicals get into the eyes, or something gets into the eyes, every second counts. And in order to properly respond to that, here's what you need to do. You need to have eye wash stations available immediately and use them immediately. When using eye wash station, you need to hold the eyelid open and flush continuously for at least 15 minutes. When a foreign object like dust or metal shaving or wood splinter gets into the eye, your first instinct is probably to rub it, right? That's the worst thing that you can do, because it can embed the object even deeper and cause more damage. So instead, don't rub your eye. Let the body's natural tears try and flush it out. To help that, you can try blinking repeatedly to encourage it to move out. And you need to use clean water at your eye wash station to flush out smaller particulate that's not embedded. And of course, seek medical help if it doesn't come out easily or if it's embedded. Never ever try to remove something from your eye yourself. Having your eye wash stations in the right locations and providing training on how to use them in emergencies can make the difference between a full recovery and permanent vision damage. OSHA requires emergency eye washes and showers to be present where the eyes or body of any person may be exposed to injurious corrosive materials. Suitable facilities for quick drenching or flushing of the eyes and body shall be provided within the work area for immediate use. And that sounds pretty straightforward at first. It says if workers might be exposed to corrosive or hazardous materials, there has to be emergency facility available for drenching or flushing. But here's the catch. OSHA tells us when and where the equipment's required. It doesn't go into explicit detail about how to properly install it, how to maintain it, or even operate it. And that's where another ANSI standard comes in. ANSI Z358.1. This ANSI standard provides best practices for selecting, installing, and maintaining of emergency showers and eye wash stations. It's what OSHA refers employers to for guidance. And in certain industries like manufacturing, construction, hazardous material handling, even telecommunications, they're all very directly affected by these requirements. Because in an emergency where every second matters, when you're dealing with things like chemical burns or contamination, the proper use of safety showers and eye wash stations can make the difference between a minor incident and a life-threatening injury. And if that happens, you're not going to have the luxury of consulting and cross-referencing OSHA and ANSI standards. Simply having emergency equipment is not enough. It has to be familiar, it has to be accessible, it has to be functional, and properly maintained to truly protect workers. Specifically on eye wash stations, obviously they don't do any good if they're blocked, broken, or forgotten about. They need to be regularly checked, and employees need to be properly trained to make sure they're ready when needed. Eye wash stations are, of course, specifically designed to flush contaminants from the eyes. There's two main types. There's plumb stations, which are directly and permanently connected to water source, and there's also gravity-fed stations, or bottles, which hold their own flushing fluid and require refilling or replacement after use. For an eye wash station to be effective, there's some critical design requirements. The flushing should reach the eyes at a height of 33 to 53 inches from the ground. The station needs to be at least 6 inches away from any obstruction so it can be accessed quickly. The fluid must flow at a rate of 0.4 gallons per minute for at least 15 minutes to help ensure proper decontamination. The eye wash stations have to activate in 1 second or less and stay on until they are manually turned off. That helps someone use both hands to hold their eyelids open and properly flush their eyes. Installation is another key factor. Eye wash stations need to be located within 10 seconds of a hazard, placed in a well-lit, clearly marked area and positioned on the same floor or level as the hazard. You don't want someone trying to run up or down the stairs or around obstacles when they need immediate eye flushing. Furthermore, weekly testing is required for the plumbed units to make sure they're working properly, and gravity-fed stations need to be checked regularly and maintained in accordance with the manufacturer instructions. Annual inspections are also necessary to help ensure compliance with the ANSI requirements. ANSI further states that the eye washes should deliver, quote, tepid flushing fluid. So what does that mean? What temperature is considered to be tepid, right? And the answer is a range of 60 to 100 degrees Fahrenheit. In short, the big takeaway here is that eye wash stations have to be immediately accessible, fully functional, in order to provide workers the best chance of avoiding permanent eye injuries. Now let's talk about emergency showers here. They're critical when workers are at risk of chemical splashes, burns, or exposure to hazardous substances. Again, there's two types. There's the plumb showers, which are permanently connected to a continuous potable water source, as well as self-contained showers. Again, standalone units with their own built-in fluid reservoir. The key specifications for an emergency shower to be effective requires firstly that the shower head is positioned between 82 and 96 inches above the surface. The spray pattern has to be wide enough to fully cover the body at least 20 inches across at a height of 60 inches. The water has to be strong enough to deliver 20 gallons per minute for a full 15 minutes. And that's a lot of water, but it's necessary to thoroughly remove any contaminants. Another important requirement is activation. Similar to eye wash stations, the valve has to be turned on in 1 second or less. And once it's on, it needs to stay on until it's manually shut off. Someone who's just been exposed to a chemical might not be able to hold that valve open while they're showering themselves off. From an installation perspective, showers have to be easily accessible within 10 seconds of the hazard and in a well-lit, clearly marked location. Again, that tepid fluid requirement applies, and the temperature range should be between 60 and 100 degrees Fahrenheit. Routine maintenance is just as important. Plumb showers should be tested weekly, and self-contained units need regular fluid checks. These annual inspections that you perform will help ensure everything is working as required by ANSI standards. The bottom line here is that an emergency shower won't help if it's too far away, blocked by obstacles, or just not functioning properly. These regular checks help ensure they're ready to be used when needed. Emergency preparedness overall is not just about meeting regulations. It's about ensuring workers are able and ready to respond if and when accidents happen. An eye wash station or emergency shower does no good to anybody if it's blocked, broken, or just forgotten about. Regular checks, proper employee training, make sure it's ready when needed. Even the best emergency equipment is completely useless if workers won't know how to use it. And that's why OSHA emphasizes training on both eye wash stations and safety showers. So what does that mean? That means employees need to know the exact locations of the emergency equipment. It means you should be conducting hands-on training so workers can practice using the eye wash stations and the showers. It also means that you should be performing emergency drills to test response time and help learn from them and reinforce best practices. In a real emergency, people need to act fast, and having that proper training helps ensure that they do. When we try to create strong safety cultures in our workplaces, there's some really effective ways that we can go about it. And specifically in fostering strong safety cultures for eye and face injury prevention, these things just don't happen overnight. They require leadership commitment, consistent PPE enforcement, selection, training. Leadership plays a huge role in just setting the overall tone for workplace safety. When managers and supervisors can actively prioritize safety, employees are far more likely to follow along. Leaders must not only talk about safety, but demonstrate it through their own actions, whether it's consistently wearing their own PPE when required or enforcing and reinforcing their policies throughout the daily operations. Strong safety culture begins at the top, period. With regard to reinforcing PPE compliance, again, it's absolutely essential that employers consistently enforce their policies, help that ensure that their workers have not only the appropriate eye and face protection for their job tasks, it's also the employee's responsibility to take ownership of their own safety and the safety of those around them. This means properly maintaining their PPE and reporting issues when they occur. This continuous training that we've talked about is absolutely critical to help workers stay informed about any new safety practices as well as evolving hazards within the workplace. Working together to encourage these safe behaviors only serves to strengthen a safety culture. We're educating workers on injuries and risks and the importance of PPE, conducting regular safety inspections to help identify gaps. Implementing recognition programs can also be a powerful tool that all work together to foster a strong safety culture, which just does not happen by chance. It takes leadership, it takes training, and again, reinforcement of safe behaviors. When we implement practices like this, we can significantly reduce the risk of workplace eye and face injuries and create an environment where safety truly is a part of everything that we do. As we wrap up here, I want to touch on some emerging trends in eye and face protection. Technology is constantly advancing, and with regard to PPE, it means that it's oftentimes becoming easier to wear, which can make it more effective, more comfortable, and more user-friendly. Overall, people want to wear it more. Some of these emerging trends include advancements in the materials the PPE is made out of. They're stronger, lightweight, have a better ergonomic design, which improve wearability. There's been significant improvements to UV light protection, which is very important, as we discussed, for welding operations. There's also been advancements with augmented reality, or AR, in the form of safety glasses that feature things like heads-up displays to provide real-time hazard alerts and hands-free access to information, as well as smart PPE with integrated sensors to detect hazards in real time. As technology evolves and face protection is becoming smarter, eye protection is becoming more advanced, these are true innovations for the future of PPE. One very important consideration, though, when using any of these new types of PPE innovations, or any PPE at all, or making changes in the workplace, is that you need to perform a risk assessment before you implement them to ensure that you're not inadvertently introducing any new risks by the use of these technologies. Got one last case study here, a real incident, which is going to help highlight, again, just how critical PPE is and immediate emergency response can be. This incident happened at NorCal Beverage, where a quality control technician was handling sodium hydroxide, something that's highly corrosive. At some point, the container they were working on or with slipped, and it caused a splash of the sodium hydroxide directly into their left eye. Now, there was an eye wash station nearby, but in the heat of the moment, the worker didn't use it right away. Instead, they tried to rinse their eye with their hands, probably just out of instinct. Eventually, though, a coworker stepped in and helped them use the eye wash station, but by then the damage had already been done, unfortunately. Because of that delay, their injury was far worse than it needed to be. Sodium hydroxide causes very serious chemical burns, and every second matters when it comes to flushing it out. If they had used the eye wash station immediately, the severity of the injury most likely would have been reduced, possibly even prevented. So again, what do we learn from this? First, PPE matters. If they'd been wearing proper eye protection, likely could have prevented an injury. Second, you need to know where your eye wash stations are and how to use them before an emergency happens, because in a moment of panic, you do not want to be scrambling. And lastly, the need to act fast. The first 5 to 10 seconds after exposure are crucial for minimizing damage, and every single second that you spent hesitating can make an injury much, much worse, as in the case of this incident that we're talking about. Every injury that's prevented is a step towards a safer workplace, and this reinforces the fact that safety is truly proactive. It is not and should not be reactive. And if you take a step back and just kind of ask yourself, if this happened to you or a coworker, would you know what to do, or would you be ready to react and help someone respond the right way? For those of you that are looking to dive deeper into eye and face protection best practices, there's some really great resources out there that are available, both from OSHA, from a general industry and construction perspective. ANSI has their standards pretty widely and readily available, especially the Z87.1 safety eyewear standard that we've been talking about today. NIOSH has an abundance of workplace safety and health topics that cover best practices and injury prevention strategies, especially for eye and face injuries, as well as the American Academy of Ophthalmology Safety Resources provides insights for long-term eye health and protection. Knowledge truly is power, and the more we understand, the better we can help protect workers. To recap our most important points from today's discussion, I want to reinforce that eye and face protection is absolutely essential. These injuries are among the most common, but also the most preventable. OSHA and ANSI standards set very clear guidelines, which help ensure that PPE meets proper safety requirements. I want to reinforce that hazard and risk assessments drive PPE selection and help you choose the right protection, and that starts by understanding the risks. Lastly, emergency preparedness saves vision. If you know what to do in an emergency, you can prevent long-term damage. Working together to follow these principles, we can reduce injuries, we can improve compliance, and create a safer workplace for everyone. The right protection, worn correctly, prevents injuries. That wraps up today's webinar. Thank you all very much for your time and attention. I'd like to open it up to any questions that any of you may have.
Thank you.